Now we're going to take a look at spring graphs. And when I'm talking about springs, I'm talking about elastic potential energy, elastic force, that kind of stuff. Their graphs are usually done force versus distance, where force is on the y-axis and distance is on. Now the slope is going to be your spring constant. And if we remember in math how to get slope, slope is rise over run, change in the y direction over change in the x direction. So the spring constant will be change in F over change in distance. In this it has the distance as x, but it's the same thing. So in this particular example, the spring constant, the change in F is 10 newtons, and the change in distance is 10 meters. So our spring constant is going to be 10 newtons divided by 10 meters, which equals 1 newton per meter. So that's pretty much how you find the spring constant from a graph. Now, the area under the graph is a work. Now, when I say area of the under the graph, this is what I mean. That portion of the graph right there. As you can tell, the area of this graph is a triangle. The area of a triangle is 1/2 base times height, which means to get the work done, it's 1/2 force times distance for this graph. So let's see what the work is for this particular situation. It's 1/2 10 newtons times 10 meters, which gives us 50 joules. And that's it. That's how you find spring constant and work using an F versus D graph.